All right, good morning, guys. I want to go through the proportion test and the small sample test. So on the first one, a couple things to point out to you. It says, what's the test to see if the drug increases the cure rate at a 1%? Okay, so here's our standard, 0.675. So we want to see if it increases, if it goes up. So we'd assume the opposite and say that it would be less than that as we go through it. The other thing is, so we have a sample of 100. The alpha value, 0.01 for a proportion, so we're checking our alpha value 0.01. This is a one-tail test because we're testing to see if it increases. So when we do that, we just use our z-scores for proportion. So for each one of these, our values are going to be different. So 0.01, we wanted to test it out, so it would be 2.326. So here is the work for the first one that I went through. And I'll zoom it in a little bit. Okay, so we would go ahead and set it up. Okay, it increases, so we assume the opposite, say it's less than that. We subtract it. So when you come in here, this is 0.675, and then this is 1 minus 0.675, so I just say it's 0.325. These two should add to 1, or 100%. And then divided by that, make sure it's all underneath the square root. You should get 2.02. You do not reject. So what we're saying is this drug does not significantly increase, and that's the big part. It does not significantly increase the cure rate. So that's what we'd be explaining as we go through. On number 2, it gives us an alpha value, and it says it wants to test to see if it's equal to it. So I want to go through it. Okay, so let's go back. So we want to test, it says, is it equal to? Is there a difference between it? So if I went through, just to show it to you again. Okay, so it says test at the 0.05 level of significance to see if, there we go, does this program work? Is there a difference? It's all it's asking for right here is there a difference? So it's a two-tailed test. Again, on a two-tailed test, we set it equal to. Once we set it equal to, then we come over here. So 0.05, it's equal to, so we divide by 2. So 0.05 divided by 2 is 0.025. We come down here. So our critical values are 1.96, and that's what you saw me put up here already, is the 1.96. The reason being is, if you look at it, we wanted to go ahead and, it's equal to, so we divided it. As you go through it, again, we do not reject, meaning there's not a significant difference between these values. So when they ask, is there a difference? We'd say, no, there's no difference between these two. The other one that I want to go through was a small sample. The small sample is the one that matters the most. So I'll show you the answers for these. Where we had the most issues was coming up with our values here. So these values here, again, the first one was a one-tailed test. If you look at it, the one-tailed test, there was a used car dealer says that the mean price of a 1995 Ford was at least $16,500. We wanted to test that out, and 0.05 with a sample of 14. So when I come here, a sample of 14, it's a one-tailed test. So I'll come through here. So it's a one-tailed test, a 0.05, as we looked at it, one-tailed test, so I'm going 0.05. The sample size was 14, so 14 minus 1 is 13. So we go down and we see the intersection. And so that's 1.771. And that's where I got that 1.771 from. If you go to the second problem, on the second problem, it was the one that said the industry claims that the mean pH level of water nearby is 6.8. So if it says it equals 6.8, it's a two-tailed test. And so that's where you see that I got equal to over there. The next thing is test it, and I'll go to our critical values. So we're using a t-score now. Our sample size is, the sample size and mean and standard deviation is 19 water samples at 0.05. So it's a one-tailed test, so we're at 0.05. Again, the sample size was 19 water samples. So 0.05, 19 minus 1 is 18. And so we're right here at 18.0. Excuse me. It's a two-tailed test, so we divide by 2. So it's at 18 right here, so it's 2.101. And that's where you see where I got those. So what I want you to go through today is I want you to go through those 2 past ones. I graded them and hand them back to you, but I want you to go through and just double check and confirm your critical values. Finish up on the test that we have that's due today, and then we'll review tomorrow.